Hi everyone. Last session we discussed about some derivations on series RLC circuit. We derived the relation between cutoff frequencies and resonant frequencies, and also we derived the relation between bandwidth, next quality factor and resonant frequency. Now let us move on to the problems part. See the first problem. See the question. A series RLC circuit has R is equal to 10 ohm, L is equal to 0.1 Henry and C is equal to 100 microfarad and is connected across 200 volt variable frequency source. Variable frequency source means we can able to change the frequency of the supply. Find the first part of the question is FR that indicates resonant frequency. Second one Z means impedance at this frequency means what? At resonance frequency. Then third one is VL. What is that? VL indicates voltage across inductor. And VC. What is that? VC indicates voltage across capacitor at this frequency. Once again, at this frequency means at resonance frequency. The fourth sub question of this problem is Q factor, quality factor, and the last part of the question is bandwidth. Is it clear? Now, first let me write the given data. The given data, sir. See, R is given 10 ohm, L is given how much? 0.1 Henry and capacitance value is given 100 microfarad. Is it clear? Then any other information? Yes, supply value is given how much? 200 volts. Is it clear? First let me write series RLC circuit R, L and C. All the three elements are connected in series across variable supply. R value 10 ohm and L value 0.1 Henry and C value 100 microfarad and supply value 200 volts. Is that clear? So what is the first part of the question? Find resonant frequency for this circuit. What is the type of circuit? This is series RLC circuit. Then we already derived the formula for resonant frequency when R, L, C are connected in series. What is that formula? The first part of the question is resonant frequency. FR is equal to 1 divided by 2 pi square root of LC. This is the formula to find out the resonant frequency. Therefore, FR is equal to 1 divided by 2 pi into what is the L value? 0.1 Henry into C value 100 microfarad means 10 power minus 6 farad. Just use your calculator and find out. You will get FR is equal to 50.35 hertz. 50.35 hertz. This is the resonant frequency for given RLC circuit. Then what is the second question? Is the impedance at this frequency. See, if this is the impedance, this is the resonant frequency. At resonant frequency, the impedance of the circuit, what is that impedance of the circuit? Is exactly equal to resistance, because at resonance frequency, the inductive reactance cancels the capacitive reactance. See how the formula to find out the impedance is R plus J into XL minus XC, right? When we call it as a resonant frequency, when XL is equal to XC, when inductive reactance is equal to capacitive reactance, so XL minus XC becomes 0. So the reactive part becomes 0 at resonance frequency. Then Z is equal to R. Therefore, Then what is the second part of the question? Z at this frequency, that is nothing but R. Therefore, Z is equal to R, that is equal to 10 ohm. Okay. If impedance of the circuit, the impedance of the entire circuit is equal to 10 ohm, then what is the current? Let me represent it as IR, resonant current. We can also represent it as maximum current, because at resonant condition the current is maximum, right? So IR is equal to V by Z. Therefore, V divided by Z is nothing but R. Z is nothing but R. Therefore, V is 200 volts. 200 volts divided by R 10. Therefore, 20 ampere. So this is the, what is this? Resonant current. Our current at this frequency means at resonant frequency. So this is the second part of the question. What is the third part of the question? Find VL and VC at this frequency. See, at this frequency, once again, at this frequency means what? At resonance frequency. We already discussed, at resonance frequency, voltage across inductive reactance is exactly equal to capacitive reactance. Is it clear? But same current is flowing through these two elements, right? When same value is multiplying with same value of XL and XC, obviously VL is exactly equal to VC. VL and VC values are equal, but they will opposite direction. That's why VL and VC are equal and opposite. Therefore, first just calculate any one value, either VL or VC, then both VL and VC are equal. So let me calculate VL. The third part of the question is VL is equal to I into XL. I into XL. Let me represent R. I can replace this by IR. So resonant current into XL. We already calculated IR is equal to 20 ampere. So we need to calculate what is XL. So what is the formula to calculate XL? Let me represent it as XLR, because I am calculating inductive reactance at resonant frequency. That's why I am representing XLR. So what is the formula? 2 pi FRL, because I am substituting resonant frequency value. So 2 pi FRL. So substitute the value 2 into 3.14, or directly we can substitute pi into what is the resonant frequency value? 50.35. That is the resonant value. Then what is L? 0.1 Henry. Is that clear? Now just simplify this expression by using the calculator. You will get XLR is equal to 31.62 ohms. Therefore, easily we can calculate what is VL. So VL is equal to IR into XLR, right? What is IR? IR 200 by 10, 20 ampere. Therefore, 20 into 31.62, that is equal to 632.52 volts. Is that clear? Next step, the question is both VL and VC, right? So at resonant frequency, VL is equal to VC, that is equal to 632.52 volts. Is it clear? Because at resonant frequency, VL value is exactly equal to VC. Is it clear? So next, the fourth sub question is quality factor. So we already discussed, this is a formula to find out the quality factor. What is the definition for quality factor? Quality factor is defined as ratio of inductive reactance at resonance to the resistance of the circuit. See, quality factor is defined as ratio of inductive reactance XL at resonance to the resistance of the circuit. So what is XLR? Already we calculated, right? 31.62 divided by what is our 10 ohm. Therefore, 3.16. So, what is the quality factor value? 3.16. Next, what is the last part of the question? Bandwidth. So, the formula to find out the bandwidth, we already derived the relation between bandwidth, quality factor and resonant factor, right? So, what is the formula? Bandwidth is equal to resonant frequency divided by quality factor. We already calculated resonant frequency, how much? 50.35 divided by quality factor, yes, how much? 3.16. Answer is 15.92 hertz. So, say the problems in this chapter are easy because we already derived the standard formula. Just by substituting the given values in the standard formula, directly we can calculate the answers. Thank you. Okay, now let us move on to the second problem. See the question. A coil of resistance, coil means it is a series combination of resistance and inductance. The series combination of resistance and inductance is known as coil. A coil of resistance 20 ohm and inductance 0.2 Henry is connected in series with capacitor, but the capacitor value is not given, that is unknown value of capacitance. Connected across capacitance across 230 volts. The AC supply is 230 volts supply. The first part of the question is find the value of the capacitance. So, capacitance value is not given. So, we need to find out what is the capacitance value for which resonance occurs at 100 Hertz. Say if the resonance frequency is 100 Hertz, then what is the corresponding value of the capacitance? Is that clear? Then what is the second part of the question? A current through and voltage across the capacitor. I mean, what is the current flowing through the capacitor at this frequency? What is that frequency? Resonant frequency. Then what is voltage across the capacitor? Finally, what is the last part of the question? Q factor. First, let me draw the given circuit. A coil of resistance and inductance are connected in series, and also capacitor is also connected in series with this combination. What is the resistance value? 20 ohm. Inductance value 0.2 Henry. Capacitance value is not given, unknown value. Across a supply of 230 volts, frequency 100 Hertz. Is it clear? So, what is the first question? Find the value of capacitance for which resonance occurs at 100 Hertz. Anyhow, we know the formula to find out a resonant frequency. What is that? Fr is equal to 1 divided by 2 pi square root of LC. Is that clear? So, Fr value is given, right? How much? 100 Hertz. So, 100 Hertz is equal to 1 divided by 2 pi square root of LC. Next, just cross multiply this. Square root of LC, that is equal to 1 divided by 100 into 2, 200 pi. Square on both sides. So, LC is equal to 1 divided by 200 pi whole square. So, next, so we need to calculate C, right? So, C is equal to 1 divided by, just cross multiply L. What is L? 0.2 into 200 pi whole square. Just simplify this expression by using calculator. You will get 12.67 microfarad. So, that is the corresponding C value, capacitance value when the resonant frequency is 100 Hertz. Is that clear? Next, what is the second part of the question? The current through and voltage across the capacitor. At what frequency? At resonant frequency. At resonant frequency, the current through the capacitor is nothing but resonant current, right? So IR is equal to, this is resonant current, V divided by Z. At resonant frequency, what is Z? Z is equal to R. Therefore, V divided by R. Therefore, IR is equal to, what is V? How much? 230 volts. 230 volts divided by, what is the R value? 20 ohm. So 230 divided by 20, 11.5 amps. So what is the second part of the question? A current through capacitor is 11.5. At the same time, what is the another part of this question? The current through and voltage across the capacitor. What is voltage across the capacitor? VC is equal to IR into XC. Because all the values what we are calculating at which particular frequency? At resonant frequency. Is that clear? Therefore, in order to calculate VC, first IR already known, need to calculate XCR. What is the formula to find out XCR? 1 divided by 2 pi FRC. Therefore, 1 divided by 2 pi into resonant frequency, 100 Hertz into capacitance value. Capacitance value 12.67 microfarad, means 10 power minus 6 farads. Is that clear? Just simplify this equation. You will get XCR is equal to 1 divided by 2 pi into 100 into 12.67 into 10 power minus 6. You will get 125.67 ohms. 125.67 ohms. Therefore, easily you can calculate what is VC. VC is equal to, what is IR? 11.5 into 125.67. So, by multiplying these two, you will get 1,445.7 volts. Sorry, 1,445.3 volts. Is that clear? So, second part of the question is over the current through and voltage across the capacitor. Finally, what is the last part of the question? Q factor. So, we already know the quality factor is defined as ratio of the inductive reactance at resonance to the resistance of the circuit, or ratio of the capacitive reactance XCR at resonance to the resistance of the circuit. Therefore, Q is equal to, because we already calculated what is XCR, we can use the second formula, XCR divided by R. Therefore, Q is equal to, what is XCR? 125.67 divided by, what is R value? 20 ohm. So, you will get 6.28. Is that clear? Thank you. Okay. Now, let us move on to the next problem. Say the question, a series RLC circuit consists of 50 ohm resistance, 0.2 Henry inductance and 10 microfarad capacitor with an applied voltage of 20 volts. Determine the resonant frequency. This is the first part of the question. Determine the resonant frequency, find the Q factor of the circuit and also compute the lower and upper frequency limits and bandwidth of the circuit. Anyhow, we not yet derived this derivation. I will give the materials for this topic. Lower cutoff frequency and upper cutoff frequency means expression for F1 and F2. Directly we are using the formula for F1 and F2 in order to find out lower and upper frequency limits. This is also known as lower and upper cutoff frequencies. The one more terminology for this frequency is half power frequencies. Anyhow, first let me draw a circuit diagram for given data. RLC are connected in series across a supply of how much? 20 volts. 20 volts. What is the resistance value? 50 ohm resistance. Inductance value 0.2 Henry and capacitance value 10 microfarad. Applied 20 volt. Okay, this is the given data. So for given data, first we can calculate. What is the first part of the question? Determine the resonant frequency. We know the formula to find out the resonant frequency when R, L, C are connected in series. What is that formula? Fr is equal to 1 divided by 2 pi square root of LC. 1 divided by 2 pi square root of LC. Just substitute the values. Fr is equal to 1 divided by 2 pi into square root of, what is the L value? 0.2 Henry into 10 power minus 6 microfarad means 10 power minus 6 farad. So by simplifying this expression, this formula, you will get 112.54 hertz. What is this frequency? This frequency is nothing but resonant frequency. This is the first part of the question. Determine the resonant frequency. What is the next part of the question? Find Q factor of the circuit. What is the formula to find out the Q factor of this circuit? Yes, Q is equal to XLR divided by R. What is this? Q factor is defined as ratio of the inductive reactance at resonance to the resistance of the circuit. Okay, directly we can substitute the value. What is XLR? XLR is equal to 2 pi FRL divided by R. So let me write here. Q is equal to 2 pi into, what is FR? Anyway, we already calculated 112.54 into inductance value 0.2 Henry divided by, what is the resistance value? 50 ohm. So by simplifying this expression, you will get 2.82. This is the quality factor of this given circuit. Now, what is the last part of the question? Compute the lower and upper frequency limits and also calculate the bandwidth. Okay. These two are the standard formula to find out the lower cutoff frequencies and upper cutoff frequency. The formula to find out lower cutoff frequency, that is F1 is equal to 1 by 2 pi into minus 1 by RL plus square root of R by 2L whole square plus 1 by LC. So here we are using the second formula is upper cutoff frequency. What is that formula? 1 by 2 pi into R by 2L plus square root of R by 2L whole square plus 1 by LC. So we already know the values are given, right? R value is given, L value is given, and also C value is also given in the data itself. Directly by substituting these values in this formula, you will get F1 is equal to 92.64 hertz. F1 is equal to 92.64 hertz. The difference between these two formula is the sign. Here minus R by 2L, here plus R by 2L. So similarly, by substituting all the values of R for R, L and C, you will get F2 is equal to 132.43 hertz. So this is how directly by substituting in these two standard formula, we can calculate what is lower cutoff frequency and what is upper cutoff frequency. The last part of the question is bandwidth of the circuit. So you know the formula to calculate the bandwidth of the circuit, that is upper cutoff frequency minus lower cutoff frequency F2 minus F1. What is F2? 132.43 minus 92.64 2.64. So we'll get 39.79 hertz. This is the frequency of what is the bandwidth or the algebraic difference between upper cutoff frequency and lower cutoff frequency is known as bandwidth. How much? 39.79 hertz. Thank you. Okay, now let us move on to the one more problem. See the question. A series resonant circuit, already it is mentioned, this is resonant circuit with R is equal to 10 ohm, L is equal to 0.1 Henry and C is equal to 50 microfarad, has an applied voltage V is equal to 50 at an angle 0, that indicates there is no phase difference between voltage and current, because we know in resonant series circuit resistance, the complete impedance of the circuit is equal to resistance. In case of pure resistance, both voltage and current are in phase. There is no voltage difference between, there is no phase difference between voltage and current. That's why the phase difference is 0. With a variable frequency, find resonant frequency. That is the first part of the question. The value of the frequency at which maximum voltage occurs across inductor and capacitor. Try to understand this sentence. The frequency at which the maximum voltage drop occurs across inductor and capacitor. There is a particular frequency, at that particular frequency there is a maximum voltage drop occurs across inductor and capacitor. Again, there are two standard formulas are there in order to calculate the corresponding frequency at which the maximum voltage occurs across inductor and capacitor. We are directly using those two formula in order to calculate the corresponding frequencies. Is it clear? First, let me write the given data. I will write the circuit. R, L, C are connected in series across a variable supply. What is the resistance value? 10 ohm. Inductance value 0.1 Henry. Capacitance value 50 microfarad. So, what is the variable supply? V is equal to 50 at an angle 0. So, what is the first part of the question? Find the resonant frequency. What is the formula to find out the resonant frequency? Fr is equal to 1 divided by 2 pi square root of LC. Therefore, Fr is equal to 1 divided by 2 pi square root of, what is L value? 0.1 Henry into C, 50 into 10 power minus 6 microfarad. So, is it clear? Therefore, you will get Fr is equal to 71.76 hertz. 71.76 hertz. This is resonant frequency for this given RLC series circuit. What is the next part of the question? Find the value of the frequency at which maximum voltage occurs across inductor and capacitor. Here we are using two standard formula in order to calculate the frequency at which maximum voltage drop occurs across inductor and capacitor. Yes, okay. So, this is the formula to calculate the frequency at which the maximum voltage drop across inductor, that is represented as FL. Frequency across inductor FL max. Is that clear? The frequency at which the voltage across inductor is maximum, that is equal to 1 by 2 pi square root of 1 divided by LC minus R square C square divided by 2. Let me substitute the values. FL max is equal to 1 divided by 2 pi square root of 1 whole divided by, what is L value? 0.1 Henry into C value 50 microfarad. 50 into 10 power minus 6 minus R square. How much? R is equal to 10 square into 50 into 10 power minus 6 whole square divided by 2. Just simplify this expression by using calculator. You will get 72.08 Hertz. This is the frequency at which we can obtain a maximum voltage drop across inductor. Is that clear? So similarly, this is the formula. FC max is the frequency at which we can obtain a maximum voltage drop across the capacitor. What is the formula? 1 by 2 pi square root of 1 by LC minus R square divided by 2L square. Just substitute the values. FC max is equal to 1 by 2 pi square root of 1 divided by inductance value 0.1 into capacitance value 50 microfarad 50 into 10 power minus 6 minus 10 square R square divided by 2 into 0.1 Henry whole square. So by simplifying this expression FC max, you will get 70.28 Hertz. The slight difference. This is 0.8 Hertz. This is 70.28. So you can directly, please remember these two standard formula, just like F1 and F2. Directly by substituting given data into these formulas, directly we can obtain what is FL max and what is FC max. Thank you.